We spend our entire lives moving through a world that seems perfectly straightforward and easy to understand. From the moment we first open our eyes, we learn to treat the space around us as a completely empty, static background, a silent stage upon which our daily dramas unfold. We view the rooms we walk through, the streets we drive down, and the vast sky above as a simple, unchanging container that merely holds physical objects. To our senses, this emptiness is entirely passive, doing nothing more than providing a place for us to exist. At the same time, we perceive time as an independent, steadily flowing stream that moves forward at a constant and unyielding pace. This cosmic clock seems to tick at the exact same speed for everyone, everywhere in the universe, regardless of what we are doing or where we are going. It feels like an invisible river, carrying us all toward the future at a rate of 1 second per second, completely indifferent to our lives. These two familiar concepts of space, and when things happen, feel completely separate from one another because we experience them independently in our everyday lives. When you walk across a quiet room to pick up an object, you feel as though you are moving strictly through physical space, while time simply ticks away in the background. Your mind naturally divides the where from the when, treating them as two entirely different dimensions that never truly interact or influence one another. We plan our meetings by specifying a location and a time, confident that these two markers belong to completely different categories of existence. This intuitive separation is highly practical for our survival on this planet, but modern physics reveals that this view is merely a comfortable illusion. The reality of our universe is far more profound, showing us that space and time are actually woven together into a single, unified structure. They are not separate entities at all, but rather two sides of the exact same coin, inseparable threads of a cosmic fabric that scientists call spacetime. Every point in the universe is defined not just by three coordinates of location, but by a fourth coordinate of moment, all bound together in a seamless continuum. Let us pause for a moment to consider the sheer scale of this quiet reality. Imagine standing in a vast forest at midnight, where the trees are perfectly still, and the cold air feels completely motionless. To your senses, the space around you is dead and empty, while the night slowly passes by as an abstract concept. Yet in truth, you are suspended within an invisible four-dimensional web that connects your physical body to the farthest stars in the night sky. This web is not silent or dead. It is a highly active, breathing medium that links every event in the history of the cosmos. This unified space-time is not a passive backdrop or a rigid stage that simply sits there waiting for things to happen. Instead, it actively reacts to the presence of mass and energy, changing its shape in response to the objects that inhabit it. If you place a heavy object into this fabric, the surrounding geometry does not remain indifferent. It curves and warps to accommodate the interloper. Space-time can bend, warp, and stretch in ways that constantly challenge our natural human intuition and common sense. We are accustomed to thinking of empty space as absolute nothingness, a void that cannot possibly possess physical properties or alter its shape. Yet the universe operates on rules that defy these basic assumptions, showing us that even the purest vacuum can curve and ripple like the surface of a deep, dark ocean. This bending is not just a mathematical trick, but a physical reality that dictates how every object, from a speck of dust to a massive star, must behave. Internalizing this complex and highly dynamic structure requires us to completely abandon many of our familiar everyday assumptions about how reality works. we must let go of the comforting idea that time is absolute and that space is a fixed, unchanging stage. It is a difficult mental leap, demanding that we accept a universe where distance can shrink and time can stretch depending on how we move through it. Only by stepping away from our limited sensory experiences can we begin to appreciate the true fluid nature of the universe that surrounds us. In the final decades of the 17th century, a brilliant mind named Isaac Newton formulated a set of equations that would govern human science for generations. He described gravity as an active, attractive force, an invisible pulling power that acts instantaneously across the cold void of space. Under his view, the sun was seen as a massive anchor, constantly pulling on the earth with an invisible rope to keep it from flying off into the dark. For more than 200 years, this elegant mechanical explanation worked beautifully, allowing astronomers to map the paths of the planets with astonishing precision. Yet, beneath this mathematical success lay a deep mystery that Newton himself could not solve, as he had no way of explaining how a force could travel across millions of kilometers of nothingness without any medium to carry it. The breakthrough arrived in the early 20th century, when a young physicist named Albert Einstein looked at the problem from an entirely different angle. He demonstrated that gravity is not an active force pulling from a distance, but rather a direct consequence of pure geometry. In this new view, the cosmos is not a rigid grid where objects are pulled around by unseen tethers, but a flexible sheet that responds to the things moving through it. Every object in the universe, from a tiny speck of cosmic dust to an immense, burning star, possesses mass and energy. This mass and energy directly tell the surrounding spacetime how it should curve, pressing into the fabric and creating physical depressions in the geometry of the cosmos. The heavier the object, the deeper the curve it creates, warping the very environment around it like a heavy sphere resting on a stretched trampoline. This warped structure then acts as a guide for all other objects moving nearby, directing their motion along natural curved pathways. When a small planet orbits a massive star, it is not being pulled by an invisible force, but is simply rolling along the natural contours of this warped geometry. There is no pulling rope, no secret attraction. There is only a free object following the straightest possible path through a curved environment. Let us stand together on the side of a quiet hill at dusk, looking down at the ground beneath our feet. In our daily lives, we feel the weight of our bodies pressing into the grass, and we assume that gravity is actively pulling us down into the dirt. But as we watch the stars begin to appear in the darkening sky, we must realize that a completely different physical event is taking place. Our bodies naturally want to follow a straight path through the curved geometry of the planet, which would lead us directly toward the center of the world. The solid ground beneath us is physically preventing us from doing so, pushing upward against the soles of our shoes to hold us in place. What we feel as the heavy weight of gravity is actually this constant upward resistance of the earth, keeping us from falling freely through warped space. This astonishing perspective completely reverses the traditional cause and effect relationships that we have been accustomed to for centuries. We no longer see motion as a response to a pulling force, but rather as a passive response to the shape of the environment itself. The geometry of the cosmos determines how matter must move, while matter simultaneously determines how that geometry must bend. This beautiful circular relationship is the true foundation of our physical reality, replacing Newton's mechanical clockwork with a fluid, breathing universe. Einstein's revolutionary description permanently transformed our collective understanding of the fundamental nature of existence, showing us that the stage of the cosmos is not empty, but is itself a dynamic participant in the cosmic dance. Whenever science communicators attempt to explain the complex mysteries of modern physics to the general public, they almost always rely on visual analogies. We see these helpful diagrams in school textbooks, museum displays, and educational television programs, all designed to translate abstract mathematical equations into something our eyes can easily grasp. Among all these educational tools, none is more famous or widely utilized than the classic model of a flexible rubber sheet stretched tight, with a heavy bowling ball resting in the center. In this familiar demonstration, the heavy sphere creates a deep depression in the material, and when smaller marbles are rolled across the surface, they naturally spiral toward the center. This illustrative demonstration is highly useful for introducing the basic idea of orbital motion and showing how space is not a rigid grid. However, if we do not look past the surface of this classic visual aid, it can easily lead our thinking in completely the wrong direction. The most significant problem with the rubber sheet model is that it relies on a hidden form of circular reasoning that actually undermines the physics it tries to explain. For the heavy bowling ball to sink into the rubber sheet and stretch it downward, an external downward pulling force must already exist underneath the entire setup. In other words, the model uses the everyday gravity of our room to explain how cosmic gravity works in the void of the universe. In the actual cosmos, there is no underlying downward pull, and there is no external environment sitting beneath the fabric of reality. The true physical structure of the universe curves through itself, relying on intrinsic geometry rather than any external pulling force. Furthermore, the rubber sheet bends down into a third dimension of space, but the universe does not bend into some larger empty warehouse that surrounds it. There is no outer, higher dimensional room holding the cosmos inside its walls. Let us sit quietly in a dark room, close our eyes, and attempt to perform a simple mental exercise. Try to imagine a flat surface, like a piece of paper, that begins to bend and warp, but has no top, no bottom, and no empty space around it to bend into. As you focus your mind, you will find yourself hitting a solid, invisible wall within your own consciousness. You can easily imagine a sheet bending inside a room, but the moment you try to remove the room itself, the mental image falls apart. This struggle is a direct confrontation with the limits of our own evolutionary biology. Our human brains evolves to survive on a three-dimensional surface, navigating flat plains, avoiding obstacles, and throwing spears at moving targets. We had absolutely no evolutionary need to visualize a four-dimensional structure bending intrinsically within its own mathematical boundaries. Because of these biological constraints, our minds simply lack the sensory wiring required to visualize the true shape of reality. Every physical model we build, every drawing we create, and every everyday metaphor we design will always remain a rough, imperfect approximation of the real cosmos. We must recognize that these helpful pictures are only temporary training seals for our minds. To truly understand how the universe shapes itself, we must look beyond our visual imagination and accept that the ultimate truth is written not in rubber, but in the elegant abstract language of pure mathematics. Imagine that you are riding in a highly advanced spaceship traveling through the darkness of space at half the speed of light. If you turn on a flashlight and point it ahead of you, your common sense tells you that the beam of light should travel away from you at its normal speed, plus the speed of your ship. Yet, if an observer standing completely still on a nearby planet measures that same beam, they will not see a faster light. Against all human logic, the speed of light remains exactly the same for all possible observers, regardless of how fast they are moving or in what direction they travel. This fundamental cosmic velocity is an absolute, unyielding constant of our universe, never moving even a fraction faster or slower under any circumstances. Since this speed is completely rigid and can never change, the other two components of motion, physical space and passing time, must constantly adjust around it. They are the variables that must bend, stretch, and warp to ensure that light always travels at its absolute speed limit. Consequently, physical distances contract, and the passage of time slows down as an object travels at very high speeds. As you move faster through the cosmos, your physical ruler begins to shrink in the direction of your motion, compressing like a tightly squeezed accordion. At the same time, the clock on your wrist ticks slower and slower relative to the stationary world, as if time itself were turning into a thick, slow-moving syrup. To your own perspective, everything inside your ship feels perfectly normal, but to the outside world, you have entered a distorted reality where space and time are fundamentally altered. These baffling phenomena are not mere mathematical theories or interesting concepts confined to physics textbooks. They directly affect our modern everyday technology. We do not need to travel to distant stars to witness these strange relativistic effects, as we rely on them every single day in our normal lives. Let us look up past the blue sky, toward the silent void where communication satellites circle our planet at thousands of kilometers per hour. Up there, in the quiet coldness of Earth's orbit, these metallic machines float in a different reality where time actually passes at a slightly different rate than it does down here on the surface. They are suspended in a region of weaker gravity and higher speed, creating a complex gravitational and kinetic dance that alters the flow of their seconds. The satellites of the GPS navigation network experience time differently than the receiving devices located in our pockets and cars on the ground. Because they are moving quickly and are positioned far away from the heavy mass of the Earth, their internal clocks run slightly faster than our clocks down here. The difference is incredibly tiny, amounting to only a few millionths of a second every day. But in the realm of high precision technology, this tiny gap is a massive canyon. Without constantly correcting for these tiny time differences, our modern navigation systems would fail completely within a matter of minutes. If the computer systems did not apply the exact equations of relativity, the location on your digital map would drift by several kilometers in a single day, making the system entirely useless. Every time we use our phones to guide us through a busy city, we are experiencing a direct, practical application of warped spacetime, proving that the strangest laws of physics are woven into the very fabric of our everyday lives. The grand palace of modern science is a house fundamentally divided, ruled by two majestic frameworks that simply refuse to speak the same language. For nearly a century, our understanding of the physical world has been split into two incredibly successful but entirely incompatible theories of nature. On one side stands general relativity, the masterpiece of Albert Einstein, that beautifully explains the colossal structures of the cosmos. It describes a smooth, elegant, and highly predictable universe of geometry, governing the orbits of planets, the life cycles of burning stars, and the slow rotation of vast galaxies. In this large-scale realm, everything is orderly, and the fabric of space curves gently under the weight of massive objects, behaving like a calm and pristine desert. But when we shrink our perspective down to the microscopic scale, this peaceful picture completely dissolves into chaos. Here, we enter the strange domain of quantum mechanics, which governs the incredibly small world of subatomic particles like electrons and quarks. In this ultramicroscopic arena, there is no smooth geometry or quiet predictability. Instead, we find a wild, turbulent sea of probabilities and random events. Particles in this realm can exist in multiple places at once, teleport through solid barriers, and pop in and out of existence without warning. So long as these two theories remain confined to their own separate domains, they work with flawless mathematical precision. However, great difficulties arise when we attempt to apply both frameworks to the same extreme cosmic environments. Under normal conditions, massive things like stars are colossal, while subatomic particles are virtually weightless, so we never need to mix the two equations. But the universe contains rare, extreme environments where an immense amount of mass is compressed into an unimaginably tiny point of space. Let us travel in our minds to the deepest heart of a black hole, or to the very first microsecond of the Big Bang itself. In these extreme realms, the entire mass of a collapsing star is crushed into a physical space smaller than a single atomic nucleus. Here, we have something that is simultaneously colossal in mass and microscopic in size, forcing both gravity and quantum mechanics to collide head-on. At this point of intersection, the smooth fabric of space-time is violently ripped apart, shredded like a piece of paper caught in a powerful hurricane. The very concept of location, direction, and passing time begins to dissolve into a foaming, chaotic ocean of pure energy. When physicists try to combine the equations of relativity with the rules of the quantum world inside these environments, the mathematics fails catastrophically. The calculations begin to spit out nonsensical answers, such as infinite densities and infinite gravitational pulls. In the world of science, an infinity is not a beautiful concept. It is a warning sign, a loud alarm bell telling us that our equations have broken down completely. This magnificent clash reveals the clear limits of our current scientific knowledge, pointing to a massive missing piece in our understanding of physics. It shows us that our current maps of reality are incomplete, and that a deeper, grander law of nature remains hidden in the shadows, waiting to be found. If you hold a handful of common soil or feel the gentle rush of a cool breeze, your mind easily accepts that these things are constructed from tiny, physical atoms. But what if you look at the completely empty space between those atoms, the silent void that separates the planets, stars, and galaxies? What is this invisible medium actually made of? And what substance constitutes the raw material of space-time itself? Despite centuries of intensive scientific investigation, modern physics still cannot answer this fundamental question with any degree of certainty. One prominent group of theoretical physicists believes that the cosmic fabric is a perfectly smooth, continuous, and seamless structure. Under this view, no matter how far we could zoom into the vacuum, we would never find any underlying blocks or individual pieces, as space would remain infinitely divisible. Another group of scientists proposes a completely different view, suggesting that the universe is actually constructed from tiny, discrete pieces. They argue that space is granular, made of microscopic pixels that are far too small to be detected by any technology we currently possess. If we had examined the void at this unimaginably tiny scale, the smooth illusion of space would shatter into a complex grid of geometric loops or knots. Regardless of its ultimate composition, we now know that empty space is never completely passive or dead. At the smallest possible scales, the vacuum is constantly vibrating with restless quantum fluctuations, behaving like a boiling cauldron of energy. Virtual particles are constantly popping into existence out of absolute nothingness, colliding with one another and vanishing back into the void within tiny fractions of a second. Let us imagine plunging deep into this microscopic realm, far past the scale of single atoms, down into the deepest dark of a pure vacuum. To our normal human eyes, this region would appear completely dark, frozen and silent, representing the ultimate absence of all physical things. Yet, if we could tune our senses to the quantum frequency, we would hear a loud, energetic hum vibrating through the darkness. The empty void is not a dead, quiet stage, but a breathing canvas of energy, glowing with a restless static that never sleeps. The mystery deepens when physicists attempt to calculate the total amount of energy contained within this restless vacuum. When they apply the standard equations of quantum theory, the math suggests that even a single cubic centimeter of empty space should contain a near infinite concentration of energy. According to these theoretical calculations, the energy of the vacuum should be so powerful that it would instantly tear the entire universe apart. Yet, when astronomers look out at the real cosmos through their telescopes, they see a peaceful, stable, and slowly expanding environment. The actual energy we observe in the vacuum is 120 orders of magnitude smaller than what our best theories predict. This massive discrepancy is the largest error in the entire history of human science, a colossal mismatch that exposes a fundamental flaw in our equations. It remains one of the greatest unsolved mysteries of all time, standing as a stark monument to the limits of our collective scientific understanding. If you accidentally knock a glass of water off a kitchen table, you will watch it fall instantly toward the floor, shattering into a dozen pieces. Our instincts immediately explain this event by telling us that an invisible physical power is pulling the glass downward. We spend our entire lives imagining gravity as an active pulling force, like an invisible cosmic rope that is constantly dragging everything down toward the ground. But the deepest truth of our universe is far more surprising, revealing that this downward pull is a complete illusion. In reality, when the glass falls, it is not being pulled by any force at all, but is simply moving along the natural, unforced curved paths of spacetime. The falling object is in a state of pure freedom, gliding effortlessly through a warped geometry without any external push or pull acting upon it. A freely falling object always follows the straightest possible path through a curved, four-dimensional environment. To understand this, we can think of an airplane flying the shortest route between two distant cities on a curved globe. To someone looking at a flat two-dimensional map, the airplane appears to fly in a wide curve, but in reality, it is following a perfectly straight line across the three-dimensional surface of the Earth. In the exact same way, a falling apple or a dropping glass is simply moving in a straight line through a warped four-dimensional geometry. This leads to an astonishing realization, showing us that the physical sensation we call weight is not the feeling of gravity pulling us down. Instead, the feeling of gravity is actually our physical body resisting this natural free fall trajectory. When you sit quietly in a chair, your body wants to follow the straightest path through warped space, which would carry you directly toward the center of the Earth. The solid chair is physically blocking you from doing so, pushing upward against your body and disrupting your natural unforced motion. It is this upward resistance of the solid world, and not a downward pull from the sky that we experience as the heavy sensation of weight. Let us close our eyes and imagine jumping off a high diving board, suspended in the air for a brief, magical second. As your body rushes downward, your stomach rises and you feel completely weightless, as if the physical grip of the world had suddenly let go. During this brief moment of free fall, you are not experiencing the force of gravity. Rather, you are experiencing the complete absence of all forces. You are floating peacefully along the natural curved contours of the Earth's warped environment, perfectly aligned with the shape of space. The Earth is so massive that it physically shapes the very directions of space and time around it, causing all free paths to bend toward its center. It tilts the coordinates of the future, making the path toward the ground the most natural direction for any free object to travel. This subtle, elegant change in the geometry of our environment is what we have mistakenly called a pulling force for thousands of years. Gravity is not an active tug of war between physical objects, but rather a beautiful passive geometric property of the curved universe we inhabit. Deep in the silent darkness of the far cosmos, two colossal black holes are locked in a fatal gravitational spiral. For millions of years, they have circled one another, moving faster and faster until they finally collide in a spectacular, explosive merger that releases more energy than all the stars in the observable universe combined. This violent event is so massive that it physically shakes the cosmos, proving that space-time is never a passive, dead container or a fixed, empty box. Instead, the fabric of the universe acts as a highly sensitive, dynamic medium that actively responds to the movements of mass and energy. The catastrophic collision of these black holes sends powerful, invisible ripples rolling outward through the cosmos, known to science as gravitational waves. These cosmic tremors propagate across the dark void at the absolute speed of light, carrying information about the distant cataclysm across billions of light years. As these gravitational waves pass through the universe, they physically stretch and compress the very structure of space. If such a wave were to pass through your bedroom right now, the distance between your walls would momentarily expand and contract by a fraction of an atom's width. You would physically grow slightly taller and thinner, then shorter and wider, completely unaware of the change, because your body and your measuring tools would stretch in perfect unison. On an even grander cosmic scale, this elastic behavior reveals itself in the constant expansion of our entire universe. When astronomers observe distant galaxies, they notice that these massive stellar systems are rushing away from us at astonishing speeds. Yet, these galaxies are not flying through space like pieces of shrapnel from a central explosion. Rather, the empty space between them is physically stretching. The cosmic fabric itself is growing larger, pushing the galaxies farther apart as more emptiness is constantly created from within the universe. Let us stand on a quiet, dark beach at midnight, listening to the heavy, slow thrum of invisible ocean waves washing over the wet sand. We cannot see the deep water in the darkness, but we can feel its immense, pulsing energy vibrating through the ground. In the exact same way, our physical bodies are constantly suspended in a silent, invisible ocean of cosmic waves. The empty room around you, the air you breathe, and the solid ground beneath you are gently vibrating with the ancient echoes of distant, stellar collisions that occurred before the Earth was born. Space can expand, vibrate, and move completely independently, without needing any external medium or outer dimension to exist within. It does not require some larger, empty warehouse to grow into, as it possesses the unique ability to stretch its own boundaries from within its own geometry. This dynamic, elastic behavior proves beyond all doubt that empty space is not a state of absolute nothingness. Instead, the void is a real physical entity with its own highly complex structural properties, behaving like a silent cosmic fabric that holds the entire universe together. When we look up at the clear night sky, we are easily mesmerized by the billions of shining stars, glowing gas clouds, and massive galaxies that decorate the dark void. We naturally assume that these bright physical structures constitute the vast majority of our universe, representing the true bulk of physical reality. Yet, the modern study of cosmology has delivered a deeply humbling truth, revealing that everything we can see is merely a tiny, superficial dust speck on a vast and unseen ocean. The first major clue appeared when astronomers measured the rapid rotation of distant spiral galaxies. According to the established laws of physics, the stars at the outer edges of these galaxies are moving far too fast, spinning with such high velocities that they should fly apart into the dark. There is simply not enough visible matter, not enough stars, planets, and gas clouds to generate the massive gravity required to hold these structures together. This indicates that some unseen ghostly scaffolding must be enveloping every galaxy, holding the stars in place with an immense gravitational grip. Scientists call this mysterious influence dark matter, but this term is merely a convenient placeholder for our profound ignorance. We do not know what this shadowy substance is made of, as it does not interact with light or any other form of electromagnetic radiation. It does not emit, absorb, or reflect a single photon, making it completely invisible to even our most advanced modern telescopes. Furthermore, the expansion of our universe is not slowing down under the pull of gravity, as scientists long assumed, but is actually constantly accelerating. Some mysterious repulsive factor is actively pushing the cosmos apart, causing distant galaxies to rush away from one another at ever-increasing speeds, like a runaway train. This accelerating influence is known as dark energy, a mysterious pressure that appears to fill all of empty space, hiding within every cubic centimeter of the vacuum. Let us stand in the middle of a large, abandoned house at midnight, where the rooms are completely quiet and dark. You cannot see any movement in the air, but you can feel a cold draft brushing past your face, and you can hear the wooden floorboards creaking under an unseen pressure. You know with absolute certainty that some powerful force is moving through the silent hallways, changing the environment around you, even though your eyes see only empty space. This is the exact sensation astronomers experience when they look out at the modern cosmos. We can feel the heavy creak of the universe, and we can watch galaxies warping under immense gravitational pressure. But we cannot see the hands that are pulling the cosmic strings. These two massive puzzles, dark matter and dark energy, completely dominate the structure and the ultimate fate of our cosmos. Together, they constitute approximately 95% of the entire mass and energy of the universe, leaving all the visible stars, planets, and gas clouds to make up a mere 5%. Every physical object we have ever touched, every historical event that has ever occurred, and every living being that has ever existed belongs to this tiny, luminous minority. We are simply small passengers on a vast, dark ship, floating in a cosmic ocean ruled by invisible forces that remain completely hidden from our senses. Throughout history, human progress has been driven by our ability to measure the physical world with ever-increasing precision. We designed rulers to measure distance, clocks to track time, and powerful microscopes to reveal the microscopic structures of living cells. Yet, when we attempt to study the very fabric of space-time itself, we discover that our traditional scientific tools are completely useless. We cannot touch, see, or isolate a piece of space in a laboratory, meaning we must study its properties entirely through highly indirect clues. We are like detectives trapped inside a locked, windowless room, forced to reconstruct the outside world solely by listening to the faint echoes passing through the thick walls. Our most successful attempt to listen to these cosmic echoes relies on the Laser Interferometer Gravitational Wave Observatory, known as LIGO. This massive scientific instrument uses long, vacuum-sealed tunnels and highly stable lasers to detect the passing gravitational ripples of distant cosmic collisions. To find these ripples, LIGO must measure changes in distance that are thousands of times smaller than the physical width of a single proton. This level of sensitivity is an extraordinary engineering triumph, allowing us to detect the tiniest tremors in the structure of reality. Yet, even this highly advanced technology remains incredibly limited in what it can actually show us about the cosmos. This process is like standing on the shore of a vast, dark lake at night, watching tiny ripples disrupt the flat surface of the water. From those faint surface movements, we must try to understand the size, weight, and movements of a giant, unseen underwater creature swimming in the deep abyss below. We can detect the disturbance, but the actual nature of the fabric that is vibrating remains completely hidden from our eyes. To look closer at the individual pixels of space, we would need to construct an unimaginably powerful microscope. Yet, a fundamental law of physics prevents us from ever building such a device, creating an insurmountable barrier for human science. To inspect extremely small distances, we must use probing particles with incredibly high concentrations of energy. But if we pack that much energy into a tiny subatomic point, the energy density becomes so extreme that it will trigger a gravitational collapse. Instead of revealing the structure of space, the energy collapses into a microscopic black hole, opening a tiny dark vortex in the fabric of the vacuum. These tiny black holes would instantly swallow the probing particles and all nearby information, permanently preventing any closer physical inspection. The harder we try to shine a bright light on the smallest scales of reality, the more these tiny dark doors will open, locking the secrets of the cosmos away in absolute darkness. This implies that our inability to see the smallest details of space-time is not a temporary limitation of our current engineering that we can eventually overcome. Instead, the laws of nature itself seem to block us from ever inspecting the ultimate foundation of reality. The universe has drawn a permanent physical curtain over its smallest scales, protecting its deepest secrets behind an unbreakable wall of absolute physical limitation. Everything you can see, hear, or touch right now feels completely solid, real, and undeniable. When you tap your fingers on a wooden desk, your hand instantly stops, and your senses report that you have collided with a physical object occupying a specific location in space. Yet, the most radical frontier of modern theoretical physics suggests that this entire experience, including the very space that holds your body, is a sophisticated illusion. A growing number of physicists hypothesize that space-time is not the fundamental foundation of our reality, but rather a superficial construct. It may be an emergent property, a macro-scale illusion arising from much simpler quantum interactions, occurring at a far deeper level of existence. To understand this, we can think of the concept of wetness. A single molecule of water is not wet. It has no temperature, no viscosity, and no fluid behavior. Yet, when you gather billions of these dry molecules together, the property of wetness suddenly emerges as a collective physical sensation. In the exact same way, the individual components of the universe may not possess space, time, or gravity, but when they interact in massive numbers, space-time emerges like steam rising from a hot cup of tea. This mind-bending idea is most clearly expressed in the holographic principle, which proposes that our three-dimensional world is merely a projection. According to this model, all the complex physical events occurring in our three-dimensional space are actually generated from a distant, flat, two-dimensional boundary. Every star, planet, and human life is like a three-dimensional image floating in the air, projected from a flat surface at the very edge of the cosmos. The invisible threads that hold this grand projection together may be constructed from a phenomenon known as quantum entanglement. This bizarre connection allows subatomic particles to remain instantly linked across vast distances, sharing information faster than the speed of light. Physicists now suspect that this deep entanglement between particles is the exact mechanism that generates our sense of physical distance. Without this constant subatomic connectivity, the fabric of space would instantly unravel, dissolving the distance between things. Let us stand inside a massive, dark movie theater, watching a brilliant film play on the widescreen. The actors move through vast valleys, climbing rugged mountains and crossing deep, blue oceans, and to our eyes, the depth of the scene feels completely real. Yet, if we walk up to the screen and press our fingers against it, we find only a flat, two-dimensional surface of pure light. The vast horizons, the physical depth, and the great distances are completely empty of actual three-dimensional space, existing only as information projected onto a flat plane. If this holographic perspective is correct, curved space is simply a macroscopic property, much like temperature emerges from the random movements of heated atoms. A single atom does not have a temperature, and in the same way, a single quantum unit of reality does not possess space or geometry. This revolutionary perspective shifts the focus of fundamental physics completely away from the geometry of space toward the study of pure information. We no longer view the universe as a physical container filled with moving matter, but rather as a vast cosmic computer program where geometry is merely a user interface, and the ultimate reality is pure binary code. The true beauty of scientific exploration lies in the realization that the horizon of our knowledge always recedes as we move closer to it. We often dream of a final, triumphant moment when we will write down a single, perfect equation that explains every single phenomenon in the cosmos. Yet, the universe stares back at us with complete indifference, utterly unconcerned with whether our limited human minds can ever grasp its ultimate rules. The laws of nature operate with an elegant, silent independence, completely unbothered by our species and our frantic search for absolute answers. Every time we believe we have mastered the rules of reality, the fabric of space-time throws a new, baffling riddle in our direction. It constantly challenges our most cherished equations, demanding that we completely tear up our old textbooks and adopt entirely new ways of scientific thinking. This endless struggle is not a sign of failure, but rather a proof of the infinite richness of the cosmos we inhabit. Every solved mystery does not bring us closer to a dead end of absolute knowledge. Instead, it simply reveals a doorway into a much larger, unexplored hallway. Our current understanding of the physical world is not the final chapter of science, but is merely the very beginning of a long and beautiful dawn. We are like children standing on the edge of a vast, dark shoreline, having examined only a few small pebbles, while an entire ocean remains completely unexplored. This unresolved uncertainty should not be viewed as a defeat or a source of frustration for our curious minds. Instead, the empty spaces on our scientific maps represent an inviting path toward future discoveries, calling out to the pioneering spirit of next generations. The beauty of our existence is defined not by the final answers we hold, but by our brave willingness to ask questions in the face of the unknown. Let us sit quietly in a dark room at midnight, looking out of a window toward the silent, starlit sky. The distant stars burn with a quiet, ancient flame, and the vast emptiness of the night feels cold, motionless, and completely silent. In this peaceful moment, we must realize that even if the final secrets of the cosmos remain forever elusive, the search itself is a beautiful victory. We are, after all, simply a collection of conscious stardust, a way for the universe itself to think, feel, and wonder about its own existence. Humanity will continue to construct larger detectors, write more sophisticated mathematics, and push our instruments to the very edge of the physical limits. We will continue to measure these invisible boundaries, driven by an unyielding desire to touch the raw fabric of reality, even if the final truths remain forever out of reach. Through it all, space-time continues to surround us silently at all times, guiding our physical existence on every possible scale. It is the silent partner holding the air we breathe, guiding the gentle falling of a leaf, and carrying our blue planet safely through the dark solar system. It is woven into every second of our lives, cradling our past, holding our present, and silently carving the straight paths of our future through the curved architecture of the cosmos.